Alright, so these are our forms of our line. We have the standard form, the slope-intercept form, and the point-slope form. Each one of them can be used for different applications.
Okay, so the first form we're going to show is the standard form. If you notice, it has ax plus by equals c. Now, you're going to see the x and the y in absolutely all of these formulas we're going to do because it's part of how we graph lines on the coordinate system on the x and the y axis. But the a, b, and c in this case are going to be integers, numbers, like in the one I have an example of there, 3x plus 2y equals 6. A is represented by 3, B by 2, and C by 6 in this problem. So why do we use this form? Well, it's really good for finding the intercepts and graphing. I'll show you how we do that in a few moments here. But it's also good for analysis. It's a great way to look at a line and see it in a nice organized way. That's kind of the things we kind of look for with this. So we have 3x plus 2y equals 6. Okay, and how you can do this is for finding intercepts, which is going to help you with graphing. So what we're going to do is, if you remember that the x-intercept happens when y equals 0, and the y-intercept happens when x equals 0. So we're going to use that by saying, what happens if, let me erase this here, I don't want to do this ahead of time. So what happens when x is 0? When x is 0, we have 2y equals 6. If we divide both sides by the 2, we get 6 over 2, which is 3. So our y-intercept here happens when x is 0. So when x is 0, y is 3. So we're going to come up here to 1, 2, 3 on the y-axis and put our dot there. Now let's see the same thing for what happens when y is 0. So when y equals 0, 3x equals 6. If we divide both sides by that 3, we get x equals 6 over 3, which is 2. So our x-intercept is going to be 2 right here. So that allows us to graph our line like this. So that's why we use it for finding intercepts and for graphing. And so for analysis, we just look and we say, well, every time x goes by 3, y is going to go by 2. That's the analysis part of this. And that's kind of what you have to figure out. This is just where the line goes as far as 6. If that was 3 and we'd have something different, we'd move the line one way or another. But our slope and everything else is still going to be the same, given where we're at with the separating it out into standard form. Alright, the second form we're going to look at is the slope-intercept form. Normally we see that as the y equals mx plus b. Now if you notice, the y's and the x's are not on the both sides anymore. The y's and x's are different. Actually, the y is by itself. The x term is here with the m in front of it. Now, as you might remember, that m means the slope. And remember, slope is rise over run. So if we have a 2 there, it's 2 over 1, because we always put everything over 1. So our slope would be rise 2 over 1. And then the b is going to be our y-intercept. So why do we use this? Well, it's great for graphing. It's great for being able to pull out that slope right out of the thing and pull out that y-intercept, which is a great starting point. Take a look at our example. Y equals 2x plus 1. So let's just graph it. We know our y-intercept, we start on this side. So our y-intercept is going to be 1. So we're going to go here to the y, and we're going to go to plus 1 here. Now if this was a minus 1, we'd put it down here in the minus 1 spot. Right now it's plus 1, so we'll just leave it there. Now we can use our slope to find the next spot. So our slope is 2, and it's a positive 2. So what we're going to do, we're going to think about that as a positive over a positive. So we're going to go from there, we're going to do our rise from here. We're going to go up 2, and then we're going to go over 1. Why are we going over 1? Because remember, that's 2 over 1. We just don't write the 1 usually. So that's going to give us our positive slope. And if you notice, this is definitely a positive kind of thing. We're going up and over. We're going that way. That's a positive slope. So not only is the slope-intercept easy to graph it, because we already got a point right away there, and we already got our slope there, it's also good for seeing the line. When we look at this, we can say, oh, okay, I know this sucker is going to go that way. It's going to slope up that way because this is a positive 2. And it's going to slope up pretty good. It's not like it's going to be 1 or a half a slope is going to not lean as much. But a positive 2 slope's going to lean right up that way. And then our 1 gives us our intercept, shows us exactly where to place it. So it's a great way to see the line. Alright, and the last form we're going to look at is going to be the point-slope form. We don't usually use this as much because if you do get it somehow in point-slope form, it's always easiest to just convert it to the slope-intercept form that we just looked at previously, that second one we did. So what happens is if you happen to have just one point and just the slope, you can do this. So remember I said y and x are always going to stay in it. We have an extra y and an extra x here. What that is that's just the x and y coordinate of a certain point on a line. So if we look at this one, y minus y1. So y1 in this case is actually -2. And x minus x1. So if this is, we're going to take the opposite of this sign since it's a negative. So our x-intercept is going to be -4. I'm sorry, our y. Let me redo this. See, everybody makes mistakes, even us teachers, right? So y minus y1. In this case, y1 is actually a +2, not a -2. And y, let's put it in the y category first here. But why is it a +2? Well, because we're subtracting it. So what we're actually subtracting in this case is we're subtracting a +2. In this case, though, we're subtracting a -4. Remember, subtracting a negative makes a positive. So our x point here is going to be -4. So if we have that, well, we can say, all right, -4, 2. So let's go 1, 2, 3, 4, -4, +2, put our point there. And then we can use our slope, which is 3. So we're going to go up 3, 1, 2, 3, and over 1. And we're going to go up 3 and over 1 again if you want to kind of continue that off. It's not really great because I'm not really doing things, I don't have a perfect graph paper, but on your graph paper on your sheet, you can do this with using the actual points. And then we just connect up those lines, and that's how we get it. So it's great for analyzing if all you have is the point and the slope. And if you get it with all the integers in there, outstanding, you're great. Now if you don't happen to have a point and all you have is a slope, well now you're going to have to use something else in order to find that initial point that you can substitute in for the x1 and y1, which is again just a point on our line. This form can come in many, many different forms then, right? Because every point on here can be a different y1 and x1. Another reason why we don't quite use this as much. It's a little bit more for if that's all you have is a point and a slope, this is one way of getting it when you remember it this way.